SPSS. Mine is already open, so I'm just going to share. Please, someone should kindly share the data, please. So this is a data set. And I'm assuming that we've all opened our data. Now, we have 12 factors that have been presumed to influence people's decision to work in the informal sector. Factor one, if you look at the label, factor one says the only way to make money. Factor two says the only way to support my family. Factor three says I'm working in the informal sector while waiting for a job. Factor four says I'm in the informal sector because I'm out of job and I need to earn money. The next one says I don't want to work for someone. The next one says to complement my income. The next factor 7 says there is more money in the informal sector. 8 says it offers flexibility of working. 9 says the lack of formal education. 10 says I want to be my own boss. 11 says it's my family business. 12 says it gives me more time. So what I'm trying to bring out here is the fact that sometimes you can have a situation where you have a lot of factors. Even this 12 is still few, you know? You can have up to 30, 50, a lot of factors in your model. But you need a very meaningful, people still don't have the data sets. But you need a very meaningful number of factors that you can reasonably explain. Imagine trying to explain 30, 40 factors to someone for being the reason for something. You know, it's not easy to do so. So what we want to do here is how can we select the most important factors statistically and we present the reasons for people's decision to work in the informal sector. That is what we want to do. But before we do that, I did mention that we need to check some things here. We need to check for the sample size. We need to check for the sampling adequacy. We need to check for the Bartlett's test of sphericity. And on the next slide, there's something here. Check data reliability. I'm going to mark that in red. Check data reliability. It is very important. Even before you check the KMO and then the Bartlett's test of sphericity, the first thing you need to do is to check the reliability of your data set. And Krobach alpha has been used as a measure of internal consistency when assessing an instrument. And generally, any alpha value between 0.6 to 0.8 is considered acceptable. That's according to, although there's so much debate on the threshold of Krobach's alpha, but 0.6 and above is relatively adequate. So the first thing we do to our data is to examine the reliability. So I'm going to go to the data now. For you to check the reliability of your data, you go to Analyze. Then you come down to this place, Scale. Analyze. Then you go to Scale. Under Scale, you choose Reliability Analysis. Reliability Analysis. I'm going to click on Reliability Analysis like this. Ideally, you wouldn't have all this here because mine has been open. So if you've opened the reliability analysis page, you have something like this. all you have to do is to select all your variables, 12 of them. Move them in. Make sure that under model here, just below where the items are listed, make sure that you click on alpha. You have other measures of reliability here, but we want to use the Krobach alpha. So make sure that the alpha is selected. And we don't need any other statistics actually. So there's no need for any other statistics. So let's just close that and you can just say, okay. So we can see number of items is 301, then reliability statistics. Krobach's alpha, 0.633. So 0.63. Does that satisfy the condition for reliability? I think it does because the condition here says the value of alpha between 0.6, preferably and above, is deemed acceptable. So the first thing you check before you proceed to factor analysis is the reliability of your data. And that you can do by going to Analyze. I'm going to do that again. Scale, reliability. You move in all your variables, select them. If you want to move them one after the other, make sure that alpha is selected. Then you click on OK. So you have this. So what we are interested in is actually here, reliability statistics. This one here. Yeah, this one here. So we want a value that is at least 0.6 and above. Here we have 0.63, so we can say our reliability is reasonably good, even though not perfect, but it's okay for us to proceed with factor analysis. So the first thing you report is the reliability. The next thing we want to do now is to run the analysis. For us to run the factor analysis, we go to Analyze. Then you come down to Dimension Reduction. Analyze, Dimension Reduction, then you go to Factor. If you click on Factor, you're going to have this page here. If you click on Factor, you're going to have this page. So what you need to do is to move all your variables into the variables box. So here, I have 12 of them. You select all. You can have as many as possible. You go in. Now, you need to select some things. Come to descriptives. We need some univariate descriptives. Remember, I told you we needed our what? KMO and Bartlett's test of sphericity. That is our Kaiser-Meyer-Hawkins test of sampling adequacy and your Bartlett's test of sphericity. So you choose this. You need coefficients. You need the end. No, this is okay for now. We'll come back to that later. So just make sure you select initial solutions, KMO, and Bartlett's test of sphericity. Then you continue. Extraction. And I did mention earlier that we have different forms of extraction. We have what we call the principal component, the unweighted least squares, and so on and so forth. The most commonly used extraction methods in factor analysis are principal component and principal ASICs factoring. So in this case, let's use principal component. If you're interested in knowing the difference, you can make a personal search on that. You choose principal component. Here, extract. We are doing an exploratory factor analysis. If you click on fixed number of factors, that means you're deciding the number of factors you want. From the 12 variables we have, you can decide that you want only 4 factors, or you want 5 factors, or you want 3 factors. But we're going to run this first based on the eigenvalue rules, based on eigenvalues greater than 1 rule, and see the number of factors that will be extracted for us by the default setting. Make sure that you check your script plot. After that, you can click on continue. Rotation. We want to assume that our factors are uncorrelated, so you can choose varimax transformation rotation. So you can click on this. Normally to be here, if you've not used it before, it to be on varimax. You change it to varimax like this. And then you can click on continue. For now, don't worry about scores. We don't need the scores. So let's run the analysis and see what we're going to have. Okay. Boom. The beauty of SPSS, you know. You have so many outputs, and your only task is how to explain them. Your only task is how to explain them. So we are done with running our factor analysis. The next minute will be used in explaining in detail.
Please go over it again. Please go over it again.
If I should do what?
Go over it again.
Before this, hello.
Yeah.
When just you import the data or
We didn't import data. I already sent the data earlier.
Yes. How did you adjust it? Could you once show us?
How to run the analysis, you mean?
No, how just you give value for each factors on the data?
I don't understand you. Can you? I don't understand the question. Can you let me understand? Yeah.
Maybe saying
Okay, so
the process.
Are you talking about the data?
yes,
No.
yes.
Oh my God.
I think I explained the data before I even went to do the analysis, you know. But let me go over it again. This is the
Okay,
data.
sorry.
Do you
Thank
have
you.
the data? Wait, do you have the data?
Yes, I have.
Good. Now, this data, actually, this data is my data. This is the data I used during my undergrad research. Part of it, you know. And
Okay.
in this data, this is my part of the data I use for my undergraduate thesis, you know. It was conducted in Ho. Ho is the capital of Volta region in Ghana. And part of the variables is that, you know, my study was centered on opportunities and constraints in the informal sector. So one of the objectives was to identify the factors influencing people to work in the informal sector. So in the questionnaire, it was a primary data. In the questionnaire, what I did then, of course, with my limited knowledge, you know, and then the guidance of my supervisor. So we had series of data, which I just brought this 12 for demonstration purposes. This wasn't there. This was added to the data after I ran the analysis. So I'm going to clear it away. So in this data set, we use a 5-point Likert scale. Come here. Let me clear. This one wasn't part of it. It was added because I ticked add scores. Okay. This is the original data. Now,
Okay.
it's a code.
At here.
So factor 1 is 1. The only way to make money, meaning I don't know any other way to look for money than to work in the informal sector. So this is how it was captured. 1 for strongly disagree. Strongly agree. 2 for agree. 3 for undecided. 4 for disagree. And 5 for strongly disagree. So this is how the data was captured with a questionnaire. Do you understand that?
Okay. Yes,
So,
yes.
okay, so that's how the data was captured. So it's
Okay.
a questionnaire. I don't know if it's still open. I can show you. It's not open, but I can actually show you. So in the original work, it looks like this. Looks like this. Let me show you. It looks like this. Looks like this. Looks like this ASP work. Yeah. The original work, I think this should be it. Let me show you. Open. Yeah, if you can see my screen, it looks like this.
Yes.
Yeah, if you can see my screen, this is the original data. This is my undergrad analysis, my undergrad thesis. Okay, in the original work, it looks like this. Data. Okay. I'm looking for the question. Actually, I need to go down.
Yeah.
The questionnaire. Yeah. This is the questionnaire. Okay, this. Okay, there's one. Problems and constraints affecting informal sector. So this is the scale. Can you see it? So people were asked to choose. So this is the problems. This other part is the factors influencing people to work. But this, I use it twice. This section is multiple section. Then the other section was for the factor analysis. So people were asked to choose. What's your constraint? Here, the other one is, the second phase of the data is, this is the only way I know to earn money. So somebody would choose either agree or strongly disagree. So this is how the data was collected. Do you get it now?
Yes, yeah.
Yeah, so that's how the data was collected. Thank you.
Okay, thank you. Thank you very much.
Yeah, so we go back to SPSS. So what you have here is an extract from that data. I just truncated it and brought this part for us to run the practice analysis with. So we have this data set. So we have 12 factors that presumably, it's an assertion, it's a hypothesis that has not been tested. So I'm assuming that these are the factors motivating the residents in Ho, which is the capital of Volta region, to work in the informal sector. So we run the factor analysis again. You go to analyze. We go to dimension reduction. We go to factor analysis. You click. By default, you're not going to have all this here. So you select all the variables like this. Now you go to descriptives. Select univariate descriptives. Univariate is your normal descriptives, your mean, yeah, that's what it means. Univariate descriptives. Check your initial solutions. And it is very important that you select the KMO and Bartlett's test of sphericity. You check it because without adequate KMO and Bartlett's test, you can't continue with your factor analysis. You can't explain the result. So you continue. We go to extraction. I said for now, we'll do principal component, which is one of the most commonly used extraction methods. A commonly used method again is the principal axis factoring. If you're interested, you can take a quick Google look at this when you have time. It's very self-explanatory later. Then you can say continue. Make sure that you select your script plot as well. You click on continue.
Hello.
Rotation.
Hello. Just on I think the previous step, when do we click on where we can just limit our variables, maybe the outcomes to just 4 or 5? Anyways, I think maybe you've not gotten to that, but yeah, you had talked about it previously. Like just on the previous click before you came.
We'll do that. Please, I would like the fact that we keep our questions. When I'm done in a section, then I'll open the ground for questions, okay? So if you have a question, just write it down. Then when I open the ground for questions so that we can, because when we keep breaking the presentation, then people's concentration is taking it. Yeah, so if you have a question, just write it down. Then when we open the floor for question and answer, you can ask, please. Thank you so much for your consideration. Yeah. Okay. So we choose Varimax transformation, which allows the fact that our constructs are uncorrelated. If you choose something like ProMax, the underlying condition is that what your constructs are having they are correlated. So which is not what we want to do. So choose your rotated solution. This gives you a plot. Usually it's okay. Let me click it. You can click it just to explore. So we continue. Now, if you click on scores, what it does is it's going to generate scores for the newly generated factors, which you can then use in subsequent analysis. So for now, come here, click on Save Variables. Here, normally the default is like this. If you click on Save as Variables, and you choose regression, meaning you're going to have regression scores. Then you click on Continue. Then you can just click on options. We don't have anything we need there actually. So you can just click on OK. So you have a lot of output. Your job now is how to interpret. A lot of output. But the first thing you check before you continue is this guy. KMO and Bartlett's test of sphericity. Now, if you go back to our conditions, look at it here. Here. We expect that this value should be what? 0.6. But now, if you look at the analysis, look at this. This value is only what? 0.5. That means the data is not adequate for factor analysis. Yeah, based on the condition. That means the data is not adequate. Now, excuse me. That means the data is not adequate for factor analysis. However, this data set was not the original data set. Now, let me show you something. Let me run another model of this. If I open a data, let me open another data. ESP. If you have this data, I'm gonna show you something. Yeah, this is a full data set. Let's rerun this analysis again. I'm going to go through again so that you get the procedure. Analyze, dimension reduction, factor analysis. Now here are my variables. My variables are only way to make money, the real data set, flexibility, gives me this, give me that. I choose the same whatever I need, KMO, what else this? Extraction is, okay, leave it like that. Rotation, Varimax. Then I go. If I continue, look at something. Let's check again. Okay. This is the original data set. I truncated that just so we have both scenarios. In the original data set, my KMO value was 0.634. But if you look at the first one we did, I did this so that we look at, you see, to emphasize the need for appropriate data collection procedure. Analysis is easy. But if you've collected your data and then the data is not good, imagine you have this and you want to use factor analysis, you can't continue. That's when people start cheating, then they edit it and lie about the data, you know? So if you don't collect your data properly, you face a situation like this and you can't run factor analysis. So this is original. But we are still going to proceed with the original data set. I just did this to demonstrate the importance of reliably collecting the data set. So this is the original value. No. This is the original value. Where is it? Yeah, this is the original value. 0.634. Now this 0.634 satisfies a condition here that my KMO test should have at least 0.6 value. Now, the next thing we want to consider is our Bartlett's test of sphericity. Now, this one, we just want to make sure that the p-value is less than 0.05. So we go to the output. You can see here, Bartlett's test of sphericity. 0.
Time to bring you all of the Premier League team news. Starting off with the early kick-off at Selhurst Park. Crystal Palace boosted by the return of Michael Elise to face Manchester City, but both Chris Richards and Mark Gay remain out. Pep Guardiola will make late decisions on Kevin De Bruyne and Erling Haaland. Ederson could return.
I think we can continue now. Okay, so I was explaining a Bartlett's test of sphericity. So all you have to look at is here, the significant value. This value is 0.000. Make sure that this value is less than your prior value of 0.03. I mean 0.05. Once it's less than, that means you've satisfied this condition. In addition to your what? KMO being at least 0.60. So those are the necessary conditions before you perform factor analysis. Remember, the objective of this analysis is we want to see the salient factors. This is the objective. You must have your objective in mind here. We want to identify the salient factors motivating people to work in the informal sector. Yes, we know we have 12. Hypothetically, we have 12 assumed reasons. But out of these 12, which among them is very important? The most important consideration. That is what we are trying to find out using factor analysis. So the essence of factor analysis is to reduce a high-dimensional data into a set of variables that we can meaningfully explain. And I mentioned that the first thing you do is you check the reliability of the data set by running your Crowbank Alpha, which you can use by going to Analyze, Scale, Reliability Analysis, and then you choose this. You move your variables and choose this, and you continue. And after running that, and you have a reliable outcome from the reliability test, you check your KM1 Bartlett's test of sphericity. Make sure that they are significant. If it's not, please don't run factor analysis. Your result will not be reliable. Okay, so now that we've performed this, the task now is for us to explain all this one after the other. Very important, so pay attention. Okay. The first one is communalities. Remember, I'm explaining the terminologies while explaining the output at the same time. Communality simply refers to the percentage of the variability in each variable or construct that can be explained by the extracted factors. I'm speaking grammar. Let me go to the solution and tell you what it means. Communalities. You know, initially we assume that each of these factors contributes 100% to the decision of the individual when it comes to working in the informal sector. But from the extracted component, it means that only about 0.7% of that variability in this first factor has been what? Accounted for. That's what we mean by communalities. So the proportion of each variable's variance that has been captured or explained in the extracted factors, by the extracted factors. So the second one, only way to support family is 0.7. While waiting for a job is just 0.4, and so on and so forth. That is what communalities mean. So it means, here I said, this is the proportion of each variable's variance that can be explained by the factors. The rest is just a statistical jargon. So just keep this in mind. This is all you need to have in mind when you're thinking of communalities. Okay. Now the next thing is extraction. Do I have that here? Yeah, that's the extraction here. I've explained that. This is the initial value. This is the extracted value. Now, the next output, we look at factor. Okay, where's factor? Factor is here. This factor here. Usually, this is what you have. No. Yeah. Usually, you have your factors to be here. But don't worry about that. It's not necessary right now. Let's look at the next one. Very important one is very important. Eigenvalues. Eigenvalues are the variances of the factors. Variances of the extracted factors. So all we have to do is look at the output. Under this section, initial eigenvalues. Now, in this model, how do you determine how many factors are okay to explain our model? Just look at the total. All the total columns that are up to 1 and above are significant. Why? Because when running the analysis, if you go to analyze dimension reduction factor, let me show you something. Extraction. This rule here, the extraction should be based on eigenvalues greater than 1. So with that in mind, if I'm looking at the number of extracted components, hello? Someone saying something, okay? So based on that rule that was set before, if I'm looking at the output, I want to look at all the eigenvalues greater than 1. Here. You can see we have 4 of them. So if I'm going to base my output on the eigenvalues greater than 1 rule, it means only 4 factors are adequate for explaining people's decision to work in the informal sector. So what I've just done is to have reduced this set of 12 variables into 4. And these 4 factors explain about 64.6% of the variabilities in the decisions of people in whole township when it comes to working in the informal sector. So initially, these 12 components accounted for 100%, but these 4 are explaining 64%. But then, what if I want to, like in my initial work, what I did was, I went to the eigenvalues, the script plot. Where's the script plot? Oh, I didn't check the script plot, sorry. I need to run this again. I didn't check the script plot. Analyze. Dimension reduction. Factor. Extraction. Yeah, I didn't check the script plot, so I didn't get the script plot. I want to run the same thing, then I'll come back again. Yep. Here. It's the same thing I've explained earlier, but now this was missing in the initial one. You know, one thing about factor analysis is sometimes it can be very subjective. Now, if you're going to use the script plot to determine the number of factors to account for the variability in the model, the general rule is we're told that you look at the elbow. You assume this is an elbow. This curve is an elbow, the elbow rule. Somebody can decide now that this is the elbow. Somebody can decide this is the elbow, right? But in my initial work, my cutoff point was here, 0.5, because I assume this is a more visible elbow than 0.4. So when I ran the first analysis, it was giving me 4 factors. But when I look at the script plot, which plot the eigenvalues against the component number, I felt 5 factors are more adequate in explaining this model. So what I did then was to go back and rerun this analysis using 5 based on the elbow rule here. So we're going to run that now. And the person who asked me the question on when do you specify the number of factors to extract, please pay attention. I'm about addressing that now. So we go back again, dimension reduction, factor. I go to extraction. Now I want 5 factors, not 4. The default model extracted 4, but I want 5. So you can put 5. So if I do that and I run the model again, like this, I'm going to have, you still check for all this, make sure everything is intact, the communalities, then you can come back here. Now look at this. Now I want to extract 5 factors, even though the eigenvalue greater than 1 said 4, but I want 5. Why? Because 5 out of the 12 initial variables explains about 72% of the variability in people's decisions to work in the informal sector. So when I extracted 4, I had about 63%. But when I added an additional 1, I think I have a higher explanatory power here. So that was my reason for using 5 then. So we can see that we've improved our model by adding an additional factor. So now let's look at the script plot again. It's going to be the same, 5. This is the component matrix, and this part are usually the trickiest part of factor analysis. So please, let's pay attention. This and then the rotated component matrix. They are usually tricky and very subjective, and this is actually one of the limitations of factor analysis. Now, when you look at the component matrix here is synonymous to your factor loadings in structural equation modeling. It simply means how each of these indicators are loaded on the extracted factors. So it means that the only way to make money has 0.4 loading on component 1, but it is highly loaded on component 2. Remember, in structural equation model, we would expect our indicators to have at least 0.7 loading on the latent construct. So just have that idea in mind. So it means that this factor is highly loaded on component 2. Now, which other ones are loaded? Only way to support family is also highly loaded here. We can see that. And if you look at the third one is actually loaded here on component 5. I'm just showing you how this thing is explained, but the most important one is the rotated one. But let's pay attention to this first. I don't want to work for someone is highly loaded on component 1 Then the next one is to complement my income is highly loaded on component 3. So you just look at the point of intersection here. There is more money in the informal sector is loaded on component 1. There's flexibility, component 2. So that's how you explain the component matrix. But in your final outcome, what you really need to report is this: the rotated component matrix. Now, what the rotated component matrix and the variance transformation matrix does is it helps you to be able to explain the loadings accurately. So it shows you which ones are highly loaded and which ones are not highly loaded, so that you can meaningfully explain the output. Now let's go back to rotated component matrix. You can see here that factor 1 is loaded on component 2, extracted component 2. Factor 2, that's the variable 2, is also loaded. Now this is the tricky part of factor analysis. Let's watch. But then we can see that no other variable is highly loaded on component 2. So normally what you do is that, because 5 factors have been extracted from the original 12, you would need to rename your factors. How do you rename these factors? That is the job in factor analysis. The naming is highly subjective, as I mentioned earlier. So you have only way to make money and only way to support family. Both of them are loaded here. So that means I can call component 2 something like financial needs. So the naming has no formula. It depends on your intuition. So let me start with factor 1. I start with that because that was more obvious. So let's start naming from 1. So this is the tricky part of factor analysis. So component 1 has loadings from don't want to work for someone and want to be my own boss, and it gives me more time. So we can see there's a correlation in these 3. Number 1, don't want to work for someone. Number 2, want to be my own boss. Number 3, it gives me more time. These are the 3 highest loadings on component 1. So if I take a look at these 3, what generic name, what name can I give to these 3 that will be reflective of this factor? We can see that I don't want to work for someone, I want to be my own boss, it gives me more time. They all move towards something that has to do with what? Independence and flexibility. The individual here wants to be his own boss. He wants to be independent. So subjectively, someone else can think of something else to name it. We can say component 1 is independence and flexibility factors. So in factor analysis, this is the main challenge, renaming your factors. So we can say, because the first one is loaded on, I don't want to work for someone. The second one is want to be my own boss. It gives me more time. So we can name it, give it a generic name. That component 1 is what? Independence and flexibility. Remember, this is just subjective. If something else comes to your mind that is reflective of the 3, it's allowed. Now we've done this. We said this 2 reflects something that has to do with financial needs. Now we look at component 3. Component 3 is loaded on to complement my income, more money in the informal sector, flexibility of working. Now, this is the challenge I was talking about. You can see that flexibility of working is actually more suitable for component 1, but now here it is highly loaded here. You see that? But the other 3, where are they? The other three is to complement income, more money in the informal sector, flexibility of working. If you are confused when it comes to naming these variables, look at the correlation matrix. That's one way to guide yourself. So I'm going to go back to the correlation matrix and look at to complement, more money, and flexibility, and see which ones have higher correlations. So I go to my correlation matrix. Here's my correlation matrix. I want to see the correlation between to complement my income and more money in the informal sector. It's here, I think here, yeah. It's 0.28. No, look at this. No. Okay, yeah, 0.28. What about flexibility of working? To complement my income and flexibility of working. 0.33. I think, yeah, flexibility of working, more money. 0.37. Now you can see, then what about to complement income and flexibility of work? No, more money and then flexibility of working. 0.37. We can see they're almost very similar. So we can see that flexibility of working is actually having a very high impact here. So the challenge in factor analysis, as I mentioned earlier, is the naming of the new variables. So we can see that flexibility of working is also playing a significant role here. So we can subjectively, remember, it is subjective, name these factors something like complementary income, complementary what? Let's name it complementary income. Because we need more money and there's more money, and so it's subjective. The next one is to look at factor 4. Factor 4 is loaded on lack of formal education. You can see this one is so easy for us to name because that's the only thing loaded. When it's like this, it's very easy to name the variable. So you can say factor 4 is what? Lack of education. Lack of education. When it's like this, easy to name. But when it's not, then we have to think and think. Factor 5 is loaded on which variable? It's loaded on variable number 3 while waiting for a job. You can see it here. While waiting for a job. So that's the highest loading here. So we can call this variable what? Unemployment factor. Unemployment factor. As I mentioned earlier, this is the challenging part of factor analysis. Renaming your variables meaningfully can be a challenge.
But that value, hello?
Yeah?
But that value is a negative value. Negative 0.627, right?
Mm-hmm.
So why not choose the positive 0.410?
We are looking at absolute values here. We are looking at naming the variables. We are looking at naming the variables. We are not looking at correlation.
So the negative, the signs doesn't matter.
Yeah, we are looking at high loading. Ideally, what you would have done if you're doing this in factor SEM is to delete negative loadings. But remember, this is exploratory. In exploratory, you're not confirming, you're exploring. So
Okay, thank
after
you
we
very
have
much.
identified these factors, we can then decide to go into literature and build our model and hypothesize. Do you get the logic? Hello?
Yes, Doc, thank you very much. I
Yeah.
understood you. Yeah.
So we are looking at the loadings. So that's how. So the challenge in factor analysis is, this is the most challenging part of the whole thing. Now, after that, I think I was here, right? Which one was I using to explain? Was it here? I think I was using this to explain the loading. Oh, sorry. I thought I was using the rotated. You use the rotated component, please, not this. Sorry. I thought I was explaining the rotated. It's the same explanation, you know? Yeah, I used this for the first two. I don't know how come I went to the other one. Okay. Can you see now that if you look at the rotated factor matrix, can you see that that problem that my prof, the person who asked the question raised, you know, the essence of the rotation is, that's why initially I mentioned that this is what you use to do that. You can see when you come here that this is clear here. Please, the participant who asked the question, can you see that it's clearer here under the rotated matrix?
Yeah, sure.
Compared
sure,
to,
sure.
yeah. Sorry, I didn't know I was
Sure.
using the, yeah. So when you come here, when you rotate it, it helps you to explain it better. So you can see we don't have the problem of negative here. You can see positive, you can see positive, positive. So the essence of the rotation is to enable us to meaningfully explain the factor loadings on the components. That is the essence of the rotated component matrix. Sorry for the confusions I caused here. I didn't know I was on the. So whenever you're explaining this, please always use the rotated component matrix. What this does is that it helps you to see the loadings more clearly and you're able to meaningfully explain the loadings. So now we have 5 factors. So lack of formal education, this is the only one loaded here, so that is R factor. After that, the next thing is the varimass transformation matrix. Now, the idea behind this is to tell us which component is more important and so on and so forth. Remember, factor analysis is exploratory in this nature. So nothing is conclusive. It is exploratory. So what this one is telling me here is that in your mind, assume that these are positions, first, second, third, fourth, fifth, on the vertical axis, the columns, 1, 2, 3, 4, 5. Then assume that these are the components. What this guy is telling me is that component 1, which is, I named it independence and flexibility, is the most important consideration when people choose to work in the informal sector within whole metropolis. Of course, I have to put that. Now, you look at this. The second position goes to component 4. No, sorry. No, sorry. Here. 0.8. So component 2 is the second most important one. And we named component 2 as what? Financial needs. The third one, the third position is component number 4, which has a higher transformation here. Component number 4, we named it lack of education. Component number 4. Yeah. Lack of education. That's a third. First, second, and third. Now, the fourth position is for component number 5. And we named component number 5 unemployment factors. So fourth, then what about the last one? The last one is component number 4. Number 4? I think I gave number 4 to someone. Complementary income. That's number 3. Number 3. Yeah. So in the rotated, because we've already given this to, this one has high loading here already. Component number 4 has high loadings here, which is higher than the one here. So we've already given it to another label. So here now we can give component number 5 to the one that has not been assigned, which is to complement my income, which is the 5th factor. So as I mentioned earlier, the most difficult part of factor analysis is naming your variables. And this is exploratory. So after getting this exploratory, these ideas now, okay, 5 factors can actually play important role in motivating people's decisions to work in the informal sector. Then you can now go back to literature, as I mentioned here. Yeah, you can then go back to literature. What we have done now is what? We have explored the data here to generate a tentative model. That is what we've just done. That's why it is what? It is not conclusive, it is what? Tentative. Let me mark the keyword, you know? So what we've done so far is to look at our data and explore it and generate a tentative model. So now, based on these 5 factors, I can go back to literature and then try to build my hypothesis based on theoretical models and empirical analysis. After doing that, then I can decide to do what we call confirmatory factor analysis. So that is the whole essence of exploratory. You're exploring the data. You want to see which factors are okay for you. And that was why here I said, no, here, let me go back. Here. Is that? Yeah, here. Factor analysis can be used to simplify data, such as reducing the number of variables in regression models. So assuming I want to run a regression model, and I say my dependent variable is, let me say, it could be a dichotomous variable, and I need factors. Based on my exploratory analysis, let's go back. Let me see if I stored the factor scores. I didn't, did I? Yeah. Let's do something again. Let's run the analysis. Now watch the data. Something is going to change. Let's say I want to run a regression model based on these 5 factors. All I have to do is analyze, dimension reduction, factor. I've already moved in all the factors. There's something I didn't do, scores. So I want to save variables as scores for a regression model. So the moment I activate this, look at what's going to happen. Continue. Okay. Now, you're not going to get anything here. What you have to do is take a look at your data set. Can you see that 5 new factors or variables are now added? So you can use these standardized scores to run a regression model. Remember, you've named the 5 factors subjectively, of course. For you to be sure of the factors, you have to establish that theoretically if you want to do confirmatory factor analysis. So this is one way to use factor analysis. You can generate regression scores for further analysis. You have so many variables, you want to reduce them. When you do this, the 12 factors are now reduced into only 5. So we'll take a 10-minute break, and then when we come, we'll finish the section for today. Thank you.